Hello, this is section 9.3, testing the difference between the two means with the dependent samples. All right, so dependent samples are those who are the subjects are paired or matched in some way, so they are also called the matched pair sample. So example for the matched pair samples include before or after sample where the value of a variable for each subject is measured before a treatment or again after treatment. Duplicate measurements on the same sample. Twin or siblings randomly assigned to a different treatment, controlling for genetics and environment, and with the same variable measure after the treatment have been applied. Matched samples, where individuals are matched based on the personal characteristics such as ages, gender, and ethnicity. All right, cautions. When subjects are matched according to the one variable, the matching process does not eliminate the influence of other variables. So when the sample subjects are used for the before-after study, it is possible that the knowledge they have participated in study can influence the result. So special t-test for dependent mean is used based on the differences between the values for each of the matched pairs. Expected mean of the difference of the matched pairs we call the mu of d, and the difference of the variables that pair of the data are d equal to x of 1 minus x of 2, and mean of the differences of the matched pair of the data where n is the number of the pairs of the data, d bar is this, and then standard deviation of the differences, we use these formulas, okay, from this. Okay, let's look at the next page. So estimate the standard error of the difference, which is d bar, which is come out as s of d bar, which is s of d divided by square root of n. So formula for the t-test value of the dependent sample. So we are using these formulas. Degree of freedom is n minus 1. So assumptions for the t-test for the two means when the samples are dependent, samples are random, and then sample data are independent, and when the sample size are less than 30, and then the population must be the approximately normally distributed. Okay, so procedure for the testing difference between the means and dependent sample. So state the hypothesis, identify the claim, and find the critical value, compute the test value, and then which is we gotta fill it in the table with the A, make a table, and then find the difference, place of the results in column A. C is to find the mean of the difference from the column, and then square the difference to the place the results in column B, which is this one, and then to find the standard deviation of the differences, which is use the formula we have, and then to find the test value using the formula we have, and then make a decision and summarize the results. Okay. All right. Let's look at the example one. Optical course times. Optical course was set up on a campus, and 8 randomly selected volunteers were given a chance to complete it while they were being timed. They then samples of new energy drinks and were given the opportunity to run the course again. The before and after times, the seconds are shown. So there are 8 students and before and after. Okay, so is there sufficient evidence at the alpha equal to 0.05 to conclude that the student did better the second time? So step 1, we need to state the hypothesis and identify the claim. So h of 0, which is our hypothesis, is going to be the mu sub d equal to 0. So difference is going to be 0. But this time, second time is going to be the higher. So we're going to call the right tail. Okay, so find the critical value, because since the alpha equal to 0.05, and then degree of freedom is going to be a 7, so critical value come out as 1.895. Okay, so and then compute the test value. So we're gonna make a table. So we have a table here. This is a table. And then find the difference and place the results in the column A. But first of all, I need to fill the data first, okay? So x of 1 is before, x of 2 is after. So I'll go 67, 72, 80, 70, 78, 80, 77, 8, 82, 69, So I got 1, 2, 3, 4, 5, 6, 7, 8. So I just have a, okay, and the x of 2, I put at 70, 76, 65, 75, 78, 65, and 68. Okay, so this is how to make the table. And then number 2, difference, we need to find the difference from the x of 1 minus x of 2. So x of 1 subtract the x of 2, which is that. And you are getting -1 and 2, and then 4 and 5, and then 3, 4, and then 4, and then the 7. And then the C, we need to find the difference of the mean of the difference, okay? So which means we need to add it up. So we're adding all the difference together, which is come out as a 28. And then the last column, we are looking for the square of the difference and place the result in the column B. So this is column A and this is column B. So column D, we need to square the column A, which is going to be 1, 4, 16, 25, 9, 16, 16, and 49. And we also need to find the sum of it, which is come out as 136. Okay, so we'll use this later. All right, and then F, we have to find the test value, which is, I think I'm missing in here. Hold on a second. Yeah, I think the E and F is kind of changing here. Okay. The E. Oh, let's do the standard deviation first. Okay, so find the standard deviation. Okay, so you just need to plug it into the formula. Okay, so n is 8 times of sigma sub d square is 136. Subtract sigma sub d is a 28 square over 8 times 7, which is you got 1088. Subtract 784 over 56, and then I got 304 over 56, come out as 2.33. Okay, next page. And then I'm going to find the test value. So test value, which is the T, is, the formula is d bar minus mu sub d over s sub d over square root of n, then 3.5 subtract 0 over 2.3 over square root of 8. And then I got 4.304 with a degree of freedom, which is a minus a subtract 1 equal to 7. Okay, and then we need to make a decision. So now what you need to do is critical value is 1.895, which is a right tail. So 1.895, and then the test value is come out as 4.3, so about here, right? So 4.304, which is in the critical region. So because of that, we need to reject the null hypothesis. Also, if you use the p-values using the test value in the table, so p-values about come out as 0.005, and compare the alpha, which is 0.05, which is a true, so we still need to reject the null hypothesis, okay? All right, so summarize. So which means there is sufficient evidence to conclude that the students did better after drinks the energy drink. All right, now the example 2, we are using the confidence intervals to see what it is, okay? So the confidence intervals are using those formulas, okay? All right, so the problem we just had it was d bar was 28 over 8, which is 3.5. And then the degree of freedom, which is a minus 1 equal to 7. And then find the t sub alpha over 2, which is 2.365 from the one tail, which is alpha was 0.05. And then S of D was 2.33, and then N equal to 8. Now plug it in. So D bar, subtract the T sub alpha over 2 of 2D and radical N, which is a mu sub 0, is D bar plus T sub alpha over 2 times SD over radical N. So D bar is 3.5. Subtract 2.365. And the SD is 2.33 over 8 square root of, which must be the mu sub 0, and D bar, which is 3.5, plus 2.365 of 2.33 over square root of 8. And then simplify 1.55, mu sub 0, and 5.45. So which is the mu sub, there's no 0. So 0 is not included. So in the confidence interval, which indicates that the null hypothesis is rejected. Okay. Alrighty. Okay, so let's look at the next problems, okay? So example 3, automobile part productions. In an effort to increase the production of automatic parts, the factory manager decides to play music in the manufacturing area. 8 workers are selected and the number of the items each produced for a specific day is recorded. So after 1 week of the music, the same worker are monitored again and data are given. So worker, there are 8 workers and before and after. And then alpha is 0.05. Can be the manager conclude that the music has increased the productions, okay? Okay, so H of 0. So D is equal to 0. And then H of 1, so H of D is less than 0, which is a claim. And then find the critical values, which is alpha is 0.05. It's also a left tail. And then degree of freedom is 7 and equal to 8. And then critical value come out as negative 1.895. And then step 3, we need to make a table and find the difference and place the results that the D. So I'm going to write all the data, which is a 6, 8, 10, 9, 5, 12, 12 after 10, 12, 9, 12, 8, 13, 8. And then difference is going to be the negative 4, 1, negative 3, negative 3, negative 1, negative 3. And the square is 16, 16, 1, 9, 9, 1, 1, 9. And then sigma sub D is negative 16. And then sigma D square is 62. Okay, so because of that, so now find the standard deviation of difference. So S of D is, so N is 8 times 62, subtract of negative 16 square over 8 times 7. And then becomes the 240 over 56, which equal to 2.07. Alright, in the F, test value, so S of D is sigma N sigma D square minus sigma D square over N times N minus 1. And then I got 8 times of, oh sorry, so what am I doing? Sorry about that. I already finished the standard deviation, right? Okay, sorry about that. So find the test value here. So T equal to B bar minus mu sub B over S of B over square root of N. This is 0, which is T equal to, the D bar was negative 2 minus 0 over 2.07 over square root of 8. Come out as negative 2.733, but the critical value was negative 1.895. And then if you plug it in, that is must be about here, negative 2.733. So because of that, we need to reject the null hypothesis. And that means there is sufficient evidence to support the claim that the production increased after was added to the environment. Okay, all right. So and then if you use a p-value from using the test value, so in here the p-value come out as about which is if you use 2.733, should be between the 2.998 and 2.365, but it's a negative, so which is negative. If you put the negative, going to be negative 2.365, negative 2.998. So it's about 0.01, and then which is going to be p-values, and then 0.025 to compare with the alpha, which is 0.05. So yeah, both the two numbers are less than this. That's why we need to reject it. Okay, so you can use a p-value or the test value to compare with the critical values. All right, that's all. Thank you for listening.